today we're starting in this First Days of Algebra flip book. Okay, if you have misplaced your book, you're going to need to take some paper out to write this down. So to start out with, if you go to that first tab, which is vocabulary, there are 4 terms up here. So I'll give you a couple minutes to get that information written in. On this variables and expressions tab in your book, just a review again of some things. The first one says multiplication can be shown in algebra by, and there's different ways that we can do that. Typically, if we're just working with numbers or a variable terms, where we've grouped things together, we'll use parentheses. For example, if I'm multiplying 2 times 5, I would use parentheses to show that I'm multiplying. Because without that, it looks like the number 25. The other option is to use a raised dot. So again, if I want to multiply 2 times 5, I can use the raised dot to show that multiplication. The reason we're showing those different things for multiplication is because we don't want to use that X symbol for multiplication, because we are now introducing those variables, those letters. It confuses us if it's a multiplication symbol or if it's a variable. When we have a combination of numbers and variables, then we usually just write them together without parentheses or a raised dot. So if I wanted, for example, 2 times n, you notice there's nothing there. I could put parentheses around them. I could put the dot in between them, but because it's a number and a variable, it's not necessary. When it's just numbers, I have to use parentheses or the raised dot. Otherwise, it would just look like the number 25 instead of a multiplication situation. So with our vocabulary, we talked about that algebraic expression. When we have an algebraic expression, we talked about 2 different kinds of terms. Okay. Terms in an algebraic expression are separated with a plus or a minus sign. So this 3x put together is one term, and it is what we call the variable term. Because it has a variable, that letter in it, it is a variable term. The second term is just a number, so it is called the constant term. So that's our algebraic expression. And then we have a power expression. With that power expression, the x in this example is what we call the base. And then the small piece that is raised up is called the exponent. So with this vocabulary, it's not something where we're going to have a vocabulary quiz or have vocabulary questions on the test, but it's important that you understand the vocabulary. So if you hear it spoken by me or you see it used in a problem, that you know what it is that they are talking about. The next piece here talks about verbal phrases for the operation symbols, adding, subtracting, multiplying, and dividing. And if you look in your interactive notebook, we glued in a half-sheet page that has some examples of different words in there. So if you open that up in your interactive notebook, So we see different words that can be used for addition, subtraction, multiplying, dividing, and then there's some other things that we'll talk about a little bit later. But right now, focusing on those four basic operations. So again, whether you're seeing those words being used in word problems, we're going to look at some examples, you need to be able to identify which operation we are working with. So if you flip your page up in your flip book, example 1 says to write a verbal expression for each algebraic expression. So lots of possibilities here because again, there's different words that can be used, different ways it can be written. So not everybody's answer would necessarily look the same. Who would like to share something for problem A? Logan, can you sit up, pay attention, please? Who would like to tell me what they would write for problem A? Yes? 2 times x minus 7. What about B? What do we do for B? 5 times t to the third power. What could have we used instead of the third power? Anybody? Okay, we could use cubed instead. Either one of those is acceptable. Again, lots of different ways it can be written. And then what about C? What are we going to do for C? Similar to B, except it starts out with a fraction.
What I would have probably done is 4 to the power of 6 divided by
4. Okay, so it's not 4 to the power of 6. The P is to the power of 6. I just look at the fraction 1/4. What can I do for 1/4? How would I write that?
You could write it as in 0.25 or 1
No,
divided by 4.
we're gonna write what we see there. So we're not gonna change it to a decimal. How do I write that fraction 1/4? What does the fraction bar mean? Divided. Okay, so I heard somebody say quotient, so I could say the quotient of 1 and 4. Right. And then what are we doing with that fraction and the variable p? We're multiplying. So I could say multiplied by, just trying to get some other words instead of times all the time, multiplied by p, and then how am I going to get that exponent in there? To the 6th power. So, I'd like you to write down D, E, and F in your book. Looking at D, E, and F, okay. D and F I think are pretty self-explanatory. With E, though, E is a little bit trickier because of these parentheses. Those parentheses are there for a reason, And we need to make sure that when we write our expression that we are including that idea of those parentheses. So, for example, what I can do with this one is I can start out with 8 times. When I get to parentheses, for parentheses, I want to use the phrase, the quantity of. Okay, the quantity of. So if you see parentheses, you need to think of the words the quantity of, and vice versa. If you see the words quantity of, you know something needs to be grouped in parentheses, because otherwise our order of operations does not work. So we have 8 times the quantity of, and then we can work with what we had in the parentheses. So I have 3 times n plus 4. So something a little bit different with that one. In example 2, we're going just the opposite direction. This time they're giving us the verbal expression, the words. We need to write the algebraic expression. So when we look at G, I see the words more than. When I see the words more than, what is that telling us we're going to do? Add, subtract, multiply, or divide? Add. Okay. So lots of times people write their problems as they read them. Okay. So they would write 9 plus n. If I say that I have 9 more than something else, I need to know what that something else is before I can figure out what I have, because I have to add 9 to it. So this could also be written as 9 plus n. And because it's an addition problem, it does not matter which way it is written. For H, I see the word quotient. What does the word quotient tell me? Divide. When we divide, order matters. The first number written is always in the numerator, and we are going to use the fraction bar to indicate division. In algebra, we use the fraction bar. We do not use the division symbol. And we're not going to use that in algebra. And then I says 7 less than 3 times a number. How do you think we would write that one? 7 less than, Kenzie?
3n minus 7.
Very good. 3n minus 7. Less than is words that you need to be very careful of. Because if I have 7 less than, I'm taking away 7 from something else. If you try to write it as you read it, you would write 7 minus 3n. And that is not correct. Okay? Switching it around when it's a subtraction problem cannot be done. Okay? Addition, like for G, worked, but not with subtraction. So I'd like you to do J, K, and L. when we look at these, for J, I see this word cubed. What does the word cubed tell us?
The third power.
To the third power. So I have b with an exponent of 3 plus 12. When we look at k, this is where again we see that less than, so we cannot write it as we read it. We need to reverse it. So we need to start with half a number. How am I going to represent half a number? How am I going to write that?
Over 2.
Okay. N over 2. And then I have the minus 4. Anybody do something else instead of the n over 2?
The one.
So you did
I didn't want her
1. Okay. So what we could do here for half a number, we would do 1/2 n minus 4. So either of those would be acceptable. And then this last one, we have 6 times p. We don't need to show anything there for the multiplication. Raised to the 8th power, which means our exponent is the 8. So that's a little bit of a review of variables and expressions.